Hey everyone, I just spent the last 2 hours playing around with this, so I figured I might as well do a little educational video here. So I'm making a lemon battery. I'm doing a presentation at F&M College tomorrow, and just kind of practicing what I'm going to be doing for the lab here. Um, so lemon batteries are a little fun experiment you can do. Anyone can do this. It's really pretty easy. All you need is some copper. I don't have the big one. Some copper wire. I got this at Home Depot. 18 gauge. Some galvanized nails. Also Home Depot. Some alligator clips or wire. Lemons. And that's it. Voltmeter comes in handy. And and an LED to light up and make it a little more exciting. All right. So the basis behind a lemon battery is same principle as any battery, really. You are using a chemical reaction to generate a potential for electrons to flow, to promote electron flow, which is electricity. So what's going on here is you have a lemon that has an electrolyte in it. Electrolyte is a solution that allows electricity to flow. So in this case, it's citric acid. You plug in copper copper piece one part of the lemon, a nail here one other part of the lemon. Just ignore this for now. This is kind of well, I'll get to that later. So what's going on is the zinc in the galvanized nail, it's interacting with the electrolyte. You generate you generate zinc ions, and they give up electrons. It's called oxidation. So what ends up happening is you have a lot of electrons that build up in the zinc nail here, and they want to move to a positive area or get pulled by a more electronegative atom, which is copper. Copper is more electronegative than zinc. It wants electrons more than zinc does. So zinc gives up its electrons. The electrons flow here through an electron shunt, or I guess in this case it's flow here through the circuit, and when I connect it to there. So what goes on at the other end, at the copper end, is the electrons flow in there. They reduce hydrogen that's present in the electrolyte solution in the citric acid, free hydrogen. It's acidic. It's kind of one of the definitions of an acidic solution. There's a lot of free hydrogen around. So they reduce the hydrogen, and that gets passed off as hydrogen gas. Just kind of, if you had a microscope, you could probably see like bubbles, like a really fine microscope. You could see bubbles of hydrogen bubbling off. I read a paper actually from Syracuse University, 2001 paper. A chemist there, he did an experiment because there was a common misconception that the ionized copper in the electrolyte solution, that gets reduced, and that's what causes the potential for the electrons to flow. It turns out it's not the case, and a lot of sources for lemon batteries, they actually still perpetuate this misconception that the copper is getting reduced when it's not. It's acting as a shunt for electrons to flow from the zinc to the copper. And what ends up getting reduced actually is the hydrogen in the lemon. He set up a really neat experiment and a whole bunch of Nernst equations to calculate the free energy that's being released, and ended up also weighing the zinc and the copper. And it turns out the copper doesn't lose any mass in the process, which means there's no chemical reaction going on with the copper. It's just acting as a shunt. Anyway, so I have two lemons set up here, and I have a circuit going here, which is broken right now. The lemons are connected so starting out, I have my anode, negative terminus. I have my positive yellow wire going to the other negative, and then I'll have my positive. I have another battery, quote unquote, hooked up here. Well, I was going to hook it up. It's actually not really connected in series with these guys, so it's not really doing anything. I can actually probably unplug this and it won't impact anything. You technically don't need 2 lemons or 3 or 4. What you could do is you could line up a whole bunch of nails in a row, as you can see I was doing, and a whole bunch of copper wires, and then hook them up in series, and that can substitute. Because remember, the reaction's not going on because of the lemon. The lemon is just the electrolyte solution container. The reaction is the power being generated, the electricity is being generated, is coming from the zinc and the copper, the potential that those two create, not the lemon. So anyway, but I just wanted to I was playing around with that. I set this up first, but then I started playing around with that. Anyway, let's hook up the circuit and see if our LED lights up. Boom. Look at that. Whoops. There we go. We got a lit LED. Purely off of lemon power. Let me unplug it, or let me break the circuit. Break the circuit, and reconnect it. Reconnect it. There we go. So break it, reconnect it, just so you can kind of see. All right. This is where my daughter would proclaim science.